Okay, welcome back. So in our last video, what we had going on was we were getting started with the CubeIDE tool on the SICE Linux machines, our Ubuntu infrastructure here. And so we had created a no backup space, and we had fired the tool up, and we had created a project. And the very first time you create a project of a particular processor type, it's going to want to go and grab all the libraries. And when it does that, it's kind of a pain because it's big. Those libraries are big because they include all kinds of examples and documentation, all sorts of other stuff. Stuff that we don't necessarily care about right now, but we will down the road. And it uses that to pull what they call the hardware abstraction layer, into your codes. You know, when you actually set things up, you set up the devices, the peripherals you're going to use related to that microcontroller. It brings in the code that you need to get started. So let's go over to our screen here. So this is where it should have left us. It leaves us in this this view that comes from a tool called CubeMX, which is a configuration tool that ST used to produce, or still does produce, that is standalone. But they've also, because it's Java as well, they've integrated it into CubeIDE. So so we get the benefit of being able to, you go in there and say I want to take this pin right here and turn it into one of its other functions. I can select it. And I can, maybe I can make it the CAN transmit pin, and so whatever. I can reconfigure this processor to do what I want to do. But for now, we'll leave it at the defaults. It's got our our UART is configured, which we'll need in the later videos, and then we've got the LED configured, which we'll also need. But right now, I just want to focus on, okay, what did this thing actually drop into my project? So here's our project over here, and I'm going to go to core. And I'm going to grab just main. Of course, all C programs start in main. And it's going to ask me, hey, when you open a C file, do you want to switch to that perspective? And the answer is yes. In general, that's exactly what I want to do. So I'm going to say, remember my decision. I'm going to say yes. And so it'll plop into this other perspective. So the perspective is a way of configuring the windows for a particular mode of operation. And so for C programming, I want to be. This is a reasonable set of windows. Down the road, you may want to optimize it a little bit here or there, but basically, it's a reasonable way of looking at it. So I'm going to also get rid of this here. I don't need that right now. I don't want to look at it. If I ever want to bring it back, I can just click on it over here. But for now, what I want to do is I want to take this code that was dropped in essentially for me, which basically does a bunch of inits, and it inits the hardware abstraction layer. It inits, the particular peripherals. It brings up the clock, and then it sits and it drops into a, an infinite loop, which you're obviously going to put more code in here. So what I want to do first is I want to just build it. So I'm going to let it build, and it's grinding away, running the cross compiler. Then it should populate this, and it kind of gives me, how much RAM to. These are different, slightly different parts of RAM, and they're divided essentially for a couple reasons. One of them is performance, and the other is power. And so you might, you'll turn different RAM on and off. Anyway, so we'll talk about that later. But basically, this gives you kind of a breakdown of your how the thing, your particular program here lays out in memory. Then, of course, if you want to do debug, you can come up here and you can hit the little bug. So we want to run this on our target, and so I'm just going to say OK to all this, and you'll see it firing stuff up here. And it fired up the ST-Link debugger, and I'm going to say, yeah, remember that. I want to remember this. I want to go into the debug perspective. Again, this is an arrangement of the windows specifically for debugging. And so here we are. We are at the HAL, and if I were to switch over to my document camera, so you can take a look at my board, this little LED up here is blinking furiously. That is the LED connection, and it's this green and red. It's a multicolor LED, and it's blinking furiously because the debugger is, those are transactions from the debugger. It's going back and forth. So what we can do here is just, as you'll see in the other videos, this is really about getting started in Linux. And so from here on out, it's pretty much the same. And so if I wanted to, say, set a breakpoint right here, I could right-click and toggle a breakpoint. Notice it's got a little blue dot. And then I could run to that breakpoint. And then if I want to run again, I can do that again, just like it works. You know, once you've got it up and running, the tool works the same. And then I'll hit pause or stop, and notice that I'm sitting here in this infinite loop, which is exactly what you would expect. I'm going to stop here because I don't know that it adds a lot of value to do this. There's no difference in Linux versus running it in Windows, or theoretically running it in the Mac, although many are having trouble getting it working in the Mac. So, well, actually, I wasn't on the screen here, so let me redo that part here. Let me just let me go back and I'm going to exit this debug perspective here. So I'm going to go back to the C++ perspective. Maybe I want to, maybe I want to, I'm going to change to it. So I'm going to go back to the debug perspective here. It'll fire up the connection, talking to the board. There we go. So now I can, now I can run where I set a breakpoint here. I can set breakpoints by right-clicking in that little gutter there and toggle another breakpoint. So if I were to reset, I can now run to that breakpoint. And so, if I want to step into that function, once I get there, I can step into it. I can start, stepping through it. Of course, you'll use the hotkeys. And then when I'm done with that, I'll step out. And so I stepped out of this function. I'm sitting here in the while, and I can run, but I'm basically sitting at that loop. So you can, now basically all of the CubeIDE, once you're at this point, your CubeIDE will work fundamentally the same as everybody else's. So, all right, so I think I'm gonna stop this video right here. I think that's adequate for kind of getting up to speed on Linux. Now you would be up and running. Pretty much the rest of the videos will focus on CubeIDE, and I won't really focus on the operating system dependencies that are, the host operating system dependencies that might have been different between the different platforms. All right, more next time.